So this is Sana, a symbiotic AI for neonatal and maternal assistance. So our project is a web-based health prototype of an offline first AI assistant for community health workers. The goal is to help them identify maternal risk, generate referral guidance, and save patient records in low connectivity settings. So this homepage introduces the entire purpose of Sana. It's clearly a show tool that is designed for community health workers who may be working in rural areas to help out maternal mothers who are currently pregnant. So we kept this design simple of our page because many of the target users are field workers and the interface should be easy for them to understand and help, not overload them with technical language. The assessment page is where the community health worker contains patient details. This includes pregnancy stage, blood pressure, symptoms, and observations on the first visit. The symptoms are based on common dangers such as headache, swelling, blurred vision, bleeding, abdominal pain, fever, and also seizures. These inputs help the system identify whether the case may be low risk, moderate risk, or high risk. So let's start a new assessment over on the page. First, we enter the name, which is need to be done by the health worker. Next, we enter the age, then weeks of pregnancy. So in this case, the patient reported blood pressure of 152/100. Symptoms also include headache, blurred vision, bleeding, and abdominal pain. So once we click on the health worker clicks on assess risk, we can see there is a high risk given to us by the system. As the case is high risk, the SANA generates a referral letter. This helps the community health worker clearly communicate the patient's condition to a hospital, clinic, or a medical officer. This is useful because the health worker may not always have the time or confidence to write a structured referred note for a stressful field situation. After the assessment is done, the health worker can visit the saved records that appear. So coming now to how our project as well as our web page works. Technically, the web page is built on a React front end with a fast API backend. The front end collects patient information while the backend runs the risk assessment logic, which is connected through a local AI model through Ollama, and when it's available, generates the responses and saves them in an SQLite. The main idea and design principle behind an offline AI is that in many rural areas where this takes place, there is no internet connectivity or there is unreliable. So the system is designed to work as much as locally as it's possible. So and the patient device can stay on device. In the future, when there is internet development, the model can be directly run online as well as all the data can be synced directly with the district health system, which makes it easier for doctors as well as hospitals to access records. Now, the AI is used in this risk assessing software because we are trying to make responses easier to understand and generate referral text to support the health worker with the clear next steps. However, the safety critical risk flagging is also supported by rule-based logic systems and not only this depends on the AI model. This web page also contains an image-based pathway which can be used to make assessments on images that contain anemia, swelling. For now, for future purposes, this may be in future versions. This will also be connected with a multimodal JAMA model to analyze the images directly. So that's it for our project, and this is Sana.